Now students, let us see area of a triangle whose vertices are 2, 3, minus 1, 0, 2, minus 4. So to solve this sum we need formula. So first I am writing the formula. The area of triangle whose vertices are x1, y1, x2, y2 and x3, y3 is 1/2 modulus x1 times of y2 minus y3 plus x2 times of y3 minus y1 plus x3 times of y1 minus y2. Okay, so simply we can remember easily this formula. So first of all you have to remember this first term 1/2 modulus x1 times of y2 minus y3. So after x1 you have to write x2 and then after y2 y3 and after y3 y1. It is in circular motion. And next after x2 you get x3, after y3 y1, after y1 y2. So here 3 vertices, 3 values are only rotated. So by this way we can easily remember this formula. So to do this one we have the simple substitutions. So simple here x1 y1, x1 2, y1 3 and x2 minus 1, y2 0, x3 2, y2 minus 4. Now sorry, y3 minus 4. Now here substitute by simple substitution we get easily 1/2 modulus 2 into y2 minus y3 0 minus of minus 4 plus x2 minus 1 into y3 minus y1, that is minus 4 minus 3 plus x3, that is 2 into y1 minus y2 3 minus 0. Now simple calculation 1/2 modulus 2 into minus into minus plus, so 2 into plus 4 plus into minus 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 4 minus 3 minus 7 plus 2 into 3. Then we get here 1/2, 2 4s are right, minus into minus plus 7 plus 6. So then 1/2 into 8 plus 7 15, 15 plus 6 21. Then we get it as 21/2. Simply we got 10.5 square units. And then similar way we can find the second also. So by using the same formula we have to substitute here x1 value is minus 5, y1 minus 1, x2 3, y2 minus 5, x3 5, y3 2. Now substitute 1/2 modulus x1 minus 5 into y2 minus y3, that is minus 5 minus 2 plus x2 3 into y3 minus y1, so 2 minus of minus 1 plus x3 5 into y1 minus y2 minus 1 minus of minus 5. Then we can write it as 1/2 minus 5 minus 5 minus 2 minus 7 plus 3 into 2 minus of minus plus, so simply 2 plus 1 plus 5 into minus 1 plus 5. Now 1/2 modulus minus 5 minus 7 35 plus 3 into 3 plus 5 into 4. Then 1/2 35 plus 9 plus 20. So 1 by 2 into 35 plus 9, 44 plus 20. Then we can write it as 1 by 2 into 64. By a cancellation we get 32 square units. Okay, by this way we can find area of a triangle. So one more concept is there. If given points are collinear, then the area formed by them is simply 0. That means the area of a triangle formed by them is 0. So on this concept we have some important sum. So let us see the sum. So next concept, if given points are collinear, we have to find some missing coordinate. So let us see that one. So here we have 7, minus 2, 5, 1 and 3, k. 7, minus 2, 5, 1, 3, k. Here given that these 3 points are collinear, we have to find the value of k. Find the value of k if the given points are collinear, that is for which the given points so and so are collinear. So what is collinear? Collinear means if 2 or 3 points are lies on same line, then we can say that 3 points are collinear, or that such points are collinear. Here, if they are collinear, the given points cannot form a triangle. That means the area should be equal to 0. By that concept, by that rule, we can easily find the k value. That means while writing the solution, since given points are collinear, then the area of triangle formed by the points is simply 0. That means 1 by 2 times of x1 y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2 is equal to 0. So here we have to substitute here x1 7, y1 minus 2, x2 5, y2 1, x3 3, y3 k. By simple substitution we can get easily k value. See this 1 by 2 modulus x1 7 into y2 minus y3, that is 1 minus k, plus x2, that is 5 into y3 minus y1, that is k minus of minus 2, plus x3, that is 3 into y1 minus y2, that is minus 2 minus 1 is equal to 0. Then 1 by 2 modulus multiply 7 into 1 7 minus 7k plus 5k minus into minus plus 2, so 5 into 2 plus 10 plus 3 into minus 3. So 1 by 2 times of 7 minus 7k plus 5k minus 2k plus 10 minus 9, 3 to the 9 is equal to 0. Now we get it as 1 by 2 modulus. So 7 plus 10, 17, 17 minus 9, 8. 8 minus 2k is equal to 0. Take this 1 by 2 that side. 8 minus 2k is equal to 0 into 2 by 1. So 8 minus 2k is equal to 0. Take this modulus on right side we get, that is by removing modulus we get plus or minus on right side, so plus or minus 0. Then 8 minus 2k equal to 0. Then we can write it as 2k is equal to minus 2k is equal to minus 8. Then k is equal to minus 8 by minus 2. On cancellation we get k value 4. Okay. So this is a way to find out k value whenever the given points are ordinate. And next, now the next sum. Find the area of the triangle formed by joining the midpoints of sides of the triangle whose vertices are 0, minus 1, 2, 1 and 0, 3. Find the ratio of this area to the area of a given triangle. That means here we need to find the midpoints of the given sides of a triangle. That means here given that a triangle whose vertices are 0, minus 1, 2, 1, 0, 3. So then we have to find the midpoints of these corresponding sides. That is, let us take midpoint of BCD, midpoint of ACE, midpoint of ABF. So we, after getting the midpoints, we have to find the area of this one. And then after getting the area of triangle DEF, and also we have to find the area of triangle ABC. So after getting those two areas, we have to get the ratio. Okay. Now, first of all, find the midpoint of BC. Midpoint of BC, that is D. So midpoint formula, what is the formula? x1 plus x2 by 2, y1 plus y2 by 2, as we know already. So here x1, y1, 2, 1, x2 by 2, 0, 3. So then we can write D is equal to 2 plus 0 by 2 and 1 plus 3 by 2. So we get it as 2 by 2, 4 by 2, on cancellation 1, 2, 1, 2. So midpoint of BC is 1, 2. In similar way, midpoint of AC, that is E is equal to 0 plus 0 by 2 and minus 1 plus 3 by 2, that is 0 by 2, 3 minus 1, 2, 2 by 2. Simply 0 by 2 is 0, 2 by 2 is 1. So point E is 0, 1. And then midpoint of AB, that is F. Simply here 0 plus 2 by 2, minus 1 plus 1 by 2, that is 2 by 2, 0 by 2. On cancellation we get 1, 0. So by this way we can find the midpoints, and then we need to find the area of a triangle DEF. So by using area of a triangle formula whose vertices are x1, y1, x2, y2 and x3, y3, we can easily find area of a triangle DEF. So area of triangle DEF is equal to 1 by 2 modulus x1 times of y2 minus y3 plus x2 times of y3 minus y1 plus x3 times of y1 minus y2. Now here let us take x1 1, y1 2, x2 0, y2 1, x3 1, y3 0. Now we get x1 1, y2 minus y3, that is 1 minus 0, plus x2, that is 0 into y3 minus y1, 0 minus 2, plus x3, that is simply 1 into y1 minus y2, 2 minus 1. Then 1 by 2 into 1 into 1, plus 0 into minus 2 plus 1 into 1. So we simply we get here 1 by 2, 1 plus 0 plus 1, that is 1 by 2 into 2. So 2 gets cancelled, we get 1 square unit, that is area of a triangle DEF. And in a similar way, find the area of triangle ABC. Area of triangle ABC. So after getting that, we have to take the ratio. Now first of all, find the area of triangle ABC. So x1 is equal to 0, y1 is equal to minus 1, x2 is equal to 2, y2 is equal to 1, x3 is equal to 0, y3 is equal to 3. Now substitute here 1 by 2 into x1, 0 into y2 minus y3, 1 minus 3, plus 2 into y3 minus y1, 3 minus of minus 1, plus x3, that is 0 into y1 minus y2, that is minus 1 minus 1. Now we can write as 1 by 2, 0 into minus 2, plus 2 into 3 plus 1, plus 0 into minus 2. And then simply we can write 1 by 2, 0 into minus 2, 0, 2 into 4 plus 0. So here 1 by 2 into 0 plus 8, simply we can get here simply 8. So 1 by 2 into 8, that is 8 by 2, 4 square units. Now ratio of area of triangle DEF and area of triangle ABC, that is simply 1:4. So like this we can get this sum. Okay. Now the next one, fourth sum. Find the area of the quadrilateral whose vertices taken in order are minus 4 minus 2, minus 3 minus 5, 3 minus 2, 2 comma 3. So these 4 vertices are taken in order like this: A4 minus 4 minus 2, B minus 3 minus 5, C 3 comma minus 2, D 2 comma 3. These 4 vertices are a quadrilateral or of quadrilateral. Now we need to find the area of this quadrilateral, but we have here in this chapter area of a triangle. By using that formula only, we can easily find out the area of this quadrilateral. As we know, if we join the opposite vertices, that is D and B or A and C. I am joining D and B. We get here two triangles. So what are they? A, B, D, and other is B, C, D. If you find these two areas separately and then add together, we can get easily the area of this quadrilateral. Okay. Now let us see. Now here by using same formula. So here first of all write the relation area of a quadrilateral is equal to area of triangle ABD plus area of triangle BDC. So equation 1. Now so find the area of a triangle ABD by applying the same formula: 1 by 2 modulus x1 times of y2 minus y3 plus x2 times of y3 minus y1 plus x3 times of y1 minus y2. So by this way we can write x1 is equal to minus 4, y1 is equal to minus 2, x2 is equal to minus 3, y3 is equal to minus 5, and x2 equal to minus 3, y2 equal to minus 5, and x3 is equal to 3 and y3 equal to x3 is equal to 2, y3 is equal to 3. This triangle, no? That's why x3 is equal to y3 is equal to 3. Now by substituting we get 1 by 2 times of x1 value minus 4 into y2 minus y3, that is minus 5 minus y3 3 plus x2 minus 3 y3 minus y1, that is 3 minus of minus 2 plus x3, that is 2 into y1 minus y2, that is minus 2 minus of minus 5. So by that we can simplify this one. Minus 4 into minus 5 minus 3 minus 8 plus into minus 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 3 minus of minus plus 2, 3 plus 2 and plus 2 into minus 2 plus 5, and then 1 by 2 times of minus 4 minus 8 32 minus 3 into 5 plus 2 into 5 minus 2 3. Then we can write 1 by 2 32 minus 15 plus 6, and then 1 by 2 32 plus 6 minus 15, and then 1 by 2 32 plus 6 38 minus 15. So 1 by 2 into 23. So area of the triangle ABD is 23 by 2. In similar way, find area of triangle BDC. Area of a triangle BDC. So here we have to write 1 by 2 times of x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. Now here x1 is equal to minus 3, y1 is equal to minus 5, x2 is equal to 2, y2 is equal to 3, x3 is equal to 3, y3 is equal to minus 2. Now 1 by 2 times of x1 is minus 3 into y2 minus y3, that is 3 minus of minus 2 plus x2 2 into y3 minus y1, that is minus 2 minus of minus 5 plus x3 3 into y1 minus y2 minus 5 minus 3. Then 1 by 2 minus 3 into 3 plus 2 plus 2 into minus 2 plus 5 plus 3 into minus 5 minus 3 minus 8. Then we can write it as 1 by 2 minus 3 into 5 plus 2 into 5 minus 2 is 3 plus 3 into minus 8. At a time we can write. Now here 1 by 2 into minus 15 modulus minus 15 plus 2 3 is 6 plus into minus minus 24. Then we get 1 by 2 minus 15 minus 24 minus 39 plus 6, that is 1 by 2 into minus 33. Then we get modulus minus gets cancelled, we get 33 by 2 square units. Now after getting this we have to write here simply 33 by 2 here we got. Now here add area of a triangle, area of a quadrilateral. To get area of quadrilateral we have to add area of triangle ABC and area of triangle BDC. ABD and so from 1 we can write area of quadrilateral. Simply area of triangle ABD is 23 by 2 plus BDC is 33 by 2. So 2 LCM 23 plus 33. So we get simply 56 by 2, that is 28 square units. So by this we can get easily the area of a quadrilateral. Okay. Now let us see. The students, very important other type of sum. Find the area of the triangle formed by the points by using Heron's formula. So those points are 1, 1, 1, 4, 5, 1. So what is Heron's formula? So simply to get that one we need some concept. Here we have triangle ABC. So we need here distances of B and C, that is length of BC. Generally it is taken as A, and length of AC or distance between A and C, it is also taken as B, and similarly AB, so it should be taken as a small c. That means the length of BC is small a, length of AC is small b, length of AB is small c. So to get the length of these sides, we have to follow the distance formula only. Okay. Now after getting these distances, that is our lengths, we have to apply S formula, that is A plus B plus C by 2. That is semi-perimeter of a triangle. That means actually the sum of three sides gives us a perimeter. That perimeter is generally denoted by 2S. Then we need here S value, that is S is equal to A plus B plus C by 2. So after getting this, we have to find the area of a such a type of method. We have to write Heron's formula. Okay, by this way we can apply this formula. So Heron's formula to find out area of a triangle is square root of S into S minus A into S minus B into S minus C. So first we need here the distance between B and C, that is BC. Then we will take as small a, square root of, apply distance formula, x2 minus x1 whole square plus y2 minus y1 whole square, square root of x2 minus x1 whole square plus y2 minus y1 whole square. Here generally the points are here 1 comma 1, b 1 comma 4, c 5 comma 1. So then here we can apply this distance formula to get a square root of 5 minus 1 whole square, x2 minus x1 whole square plus 1 minus 4 whole square, y2 minus y1 whole square, square root of, simply we can write it as 4 square plus minus 3 square, that is 16 plus 9. So square root of 25, it is simply 5. And then find AC. Simply we can write small b. So then here also 5 minus 1 whole square plus 1 minus 1 whole square. Okay, x2 minus x1 whole square plus y2 minus y1 whole square. So by that way easily we can write here 4 square plus 0 square, that is 16 plus 0 root 16, simply it is equal to 4. So a value is here 5, b value is 4, and then AB, that is c is equal to square root of 1 minus 1 whole square plus 1 minus 4 whole square. Okay, that is distance between A and B. So 1 minus 1 whole square is 0 square, 1 minus 4 is minus 3 square. Simply we get 0 plus 9, that is root 9, 3. So we get it as C value 3. Now here to get area of this triangle, we can apply easily here Heron's formula. So after getting these lengths of sides, we have to apply Heron's formula. Now here see S value, that is S is equal to A plus B plus C by 2, that is A value 5, B value 4, C value 3 by 2. 5 plus 4, 9 plus 3, 12, 12 by 2, simply S value 6. So we have S value 6, A value 5, B value 4, B value 4 and C value 3. By substituting all these values, we get easily square root of 6 into 6 minus 5 into 6 minus 4 into 6 minus 3. Then square root of 6 into 1 into 2 into 3. That is simply 6 into 1, 6, 2 into 3, 6, square root of 36. Then we get it as 6 square units. So in this bit we have one more sum, then that is do yourself. That sum do yourself. Now see children, exercise 7.4 we have simple sums. Find the slope of the line joining the two given points. The first one is 4 comma minus 8, 5 comma minus 2. Let us do them also later. First let's see this. So what is the formula of a slope of line joining of 2 points. Simple formula. So to get that one, slope of a line joining the 2 points, or suppose x1 y1 and x2 y2, is simply we can write it as y2 minus y1 by x2 minus x1. Generally it is a ratio, so that is ratio is actually equated to the tangent theta, that is equal to m. Okay, so what is theta here? Simply see the simple concept. Here I am taking one quadrant, here the horizontal line is x axis, vertical line y axis, as we know already. So for suppose here the line is slopes to x axis, that is it is making an angle with the x axis theta in positive direction. So if we know the theta, then if we apply m is equal to tan theta, that is slope is equal to tan theta, then we can apply, we can get easily the slope value of that line. Okay, so but here we have x1 and y1 and x2 y2. So to get the ratio x2 y2 minus 1 by x2 minus x1, we need to have here 2 points, that is 4, 8, 5, 2 type. So if we substitute x1 and y1 and y2 and x2 in this formula, we can get easily the slope. Okay, that is the relation between the ratio and the tangent. Okay, now let us see how to find out the slope. So x1 is equal to 4, y1 is equal to minus 8, x2 is equal to 5, y2 is equal to minus 2. Now here slope y2 minus y1, that is minus 2 minus of minus 8 by x2 minus x1, that is 5 minus 4. So minus 2 plus 8 by 1, 8 minus 2, 6. So in the similar way, second one. So what is that one? 0, 0 and root 3, 3. So by that you can easily write simple. For this exercise it is enough. So after getting the theta values of in tangent, you will get easily that type of sums also. That type of means here if a straight line makes an angle so and so with the x-axis, then find the slope of the line. So in that case we can apply m is equal to tan theta, whereas here this is enough. Okay, y2 minus y1 by x2 minus x1. Now here for the second one we have x1 is equal to 0, y1 is equal to 0, x2 is equal to root 3, y2 is equal to 3. By substituting we get simply y2 minus y1, that is 3 minus 0 by x2 minus x1 root 3 minus 0, that is 3 by root 3. So rationalize this one, that means rationalize denominator. To rationalize denominator we have to multiply and dividing by the root 3, that is 3 root 3 by root 3 into root 3, root 3 whole square, square root square gets cancelled, we get 3 root 3 by 3, 3 gets cancelled, we get root 3. Okay, so like this we can get. And the next third one, third is also similar type. So here we have the x1 value is minus 3.5, make it as into improper fraction. So 3 2s are 6, 6 plus 1 7, that is minus 7 by 2, and y1 is 3, and here x2 is equal to minus 7, whereas y2 is equal to 2 into 1 by 2, that is 2 to the 4 plus 1, 5 by 2. So now here by substituting we get simply y2 minus y1, that is 5 by 2 minus 3 divided by x2 minus x1, that is minus 7 minus of minus 7 by 2. So we can write it as 2 LCM, 5 minus 2 into 3 6 by, here again 2 LCM, minus 14 plus 7. So here we can write minus 1 by 2 by minus 1 by 2 by minus 7 by 2. So minus 1 by 2 by 2 by minus 7, minus minus cancel, 2 cancel, we get simply 1 by 7. So like this we can get this type of